awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Assalamualaikum and hi everyone, welcome back to my channel. Jadi dalam video kali ini, kita nak buat lagi beberapa soalan dalam chapter 9. Dan jika anda pertama kali hadir ke channel ini, selamat datang saya ucapkan. Jika anda pernah hadir dan kembali semula, tahniah kerana rajin dan sudi kembali. Jadi dalam video kali ini, kita akan buatlah beberapa soalan berkaitan dengan chapter 9. Jom kita mula. Alright, now let's continue with example number 4. So here we have two graphs, okay, which is graph, okay, displacement against time, okay, and here we have graph V against T. Ada dua, okay. Alright, so yeah, determine the frequency of the object and the period. Okay, this is very simple. So we want to determine what is the frequency. Okay, and what is the period T? So look at here, from the graph, we already know that the amplitude of this Y against T graph is equal to 2 meter. So daripada graph, saya tahu the amplitude is equal to 2 meter. And from VT graph, we already know that V maximum, here is the V maximum, okay, is equal to 6 meter per second. Okay, and always remember that equation of V maximum. V maximum, okay, saya tak nak tunjuk lagi ya derivation ya, saya dah pernah tunjuk sebelum ni. So V maximum is equal to A omega. Therefore, from this equation, we can find omega is equal to V maximum over A, which is equal to 6 over 2. Okay, so finally you will get omega, which is the angular frequency, is equal to 3 radian per second. Okay, tapi soalan bukan suruh kita kira omega, soalan suruh kita kira frekuensi. So as we know that omega is equal to 2 pi f, therefore frequency is equal to omega over 2 pi. Okay, so kita boleh kira lah dia punya frekuensi berapa dekat sini. Substitute nilai omega equal to 3 radian per second. Okay, so you akan dapat 0.48 Hertz. Okay, so this is the frequency. And then the period, you can find T is equal to 1 over F, ataupun you kata you nak guna maklumat omega tadi, omega is equal to 2 pi over T. So T is equal to 2 pi over omega. Boleh, tak ada masalah. Ataupun you nak kata nak guna T equal to 1 over frequency, since frequency is equal to 0.48. Nah, mana-mana pun boleh. So the answer should be equal to 2.08. Okay, 2.08 seconds. Okay, kalau you guna formula ini, you akan dapat 2 pi, omega is equal to 3. Okay, so you akan dapat 2.09. Okay, dia akan lari sikit lah. Okay, 2.09 seconds. Jadi mana-mana equation you nak pakai pun boleh, tak ada masalah. Okay, so daripada graph, you mesti tahu baca graph. Okay, ini adalah maximum displacement. Maximum displacement adalah A. Okay. Tapi kalau graph V against T, nilai dekat sini adalah maximum velocity. Kalau kita ada graph A against T pula, nilai amplitude of the graph adalah A maximum. Boleh? Okay, finish example number 4. Okay, example number 5. So here we have a particle of mass 4 kg is moving in simple harmonic motion. The change in potential energy, so this is the change in potential energy U with its displacement x is shown in figure 4.0. Okay, so this is the graph of potential energy. Okay, jadi untuk potential energy, you must remember where the potential energy is maximum. Okay, U is maximum at X is equal to positive A or at X equal to negative A. Boleh? But the potential energy should be equal to 0, okay, at X is equal to 0 joule. So, kita revise balik. Terbalik dengan kinetic energy. Kinetic energy is maximum at X equal to 0. Okay, 0 meter. Okay. 0 lah. 0 meter ke, 0 centimeter ke. But kinetic energy is equal to 0 at X equal to positive A or X equal to negative A. Boleh? Okay. So, let's try to answer question A. Alright. So, determine from the graph. Okay. From the graph, determine the angular velocity of the particle. So, we want to determine the angular velocity of the particle. Alright. Which is omega. So, daripada graf ini, saya tahu ini adalah A. Okay. And this is the value. Here is 2 joule. So, this is U maximum. Okay, where the equation of U equal to half Ka squared. Alright. So, bila saya tulis dekat sini, U is equal to half Ka squared. Tetapi, soalan tanya saya angular velocity omega. So, kita boleh gantikan K is equal to M omega squared. Saya dah ingatkan sebelum ni kan? K, always remember that K is equal to M omega squared. Alright? So, from this equation, we can substitute K here. Alright? And finally, we can find omega, which is the angular velocity. So, kita masukkanlah at X equal to 0.4 meter. Okay, we can substitute U equal to 2 joule. Okay. Half. The mass is given 4 kg and omega kita nak cari A is equal to 0.4 squared. Okay. So, omega is equal to 2.5 radian per second. Okay. Boleh? Alright. So, ini sepatutnya dia letak kat sini lah meter. Sebab unit U ini dalam joule. So, ini mesti dalam meter. Boleh? Okay. Ini A1. A2, the period of the oscillation. So, this is very simple. Kita dah buat banyak kali. Omega equal to 2 pi over T. So, T is equal to 2 pi over omega. So, omega kita dah dapat 2.5. So, T you akan dapat 2.09 seconds. Okay? So, finish question A. Alright. So, now let's proceed to question B. Write an equation for the displacement of the particle in terms of the time t. Okay, so always remember that general equation of displacement dalam syllabus awak in terms of sign. Okay, so this is general equation. Okay, kalau soalan kalau soalan suruh awak tulis equation tanpa bagi apa-apa condition, kalau example number 4 sebelum ni kita ada condition. Sebab itu general equation of the displacement kita dapat cos. Okay, but this time, dia suruh kita tulis equation for displacement. So, kita consider general equation for displacement in function of time A sin omega t. Okay, so amplitude kita dah ada. Kita masukkan je lah kan. 0.4 sin omega kita dah dapat tadi 2.5 t. Okay, jangan lupa mention dia punya unit. Where X in meter and T is in second. Okay, so this is the answer. And then C, at T is equal to 2.0 second, calculate the displacement. Okay, so this is very simple. So at T is equal to 2 seconds. Okay, saya highlightkan sikit. Kita nak kira dia punya displacement. X is equal to 0.4 sin 2.5 T darab 2. So, gantikanlah. make sure your calculator in radian mode. Okay, so tekan calculator elok-elok. So you akan dapat X equal to negative 0.384 meter. Unit jangan tertinggal. Okay, and for the second part, so we want to find the velocity at t is equal to 2 seconds. Kita tak ada equation velocity. So we need to write the equation of velocity. Kita perlu differentiate. Kan, kita tahu kan tadi, V is equal to dx over dt. Okay, cuba practice macam mana nak differentiate. Okay, differentiate sign akan beri u cos. Okay, so automatically saya akan dapat V is equal to, okay, saya terus saja tulis A omega cos omega t. So this is general equation. Kalau tadi kat sini kita ada general equation untuk displacement, this is general equation of the velocity after differentiation. Okay, so V is equal to A kita dah tahu 0.4. Okay, omega kita berapa tadi? Omega kita adalah 0.5. Betul? 2.5. Cos 2.5t. Okay, so t kita berapa? Tulislah dulu kan. Kita juga boleh tulis saja dulu. Ataupun nak masukkan terus pun bolehlah. T kita adalah 2 seconds times 2. So, V 0.4 times 2.5. Okay, times cos. Ini pastikan awak ni selesaikan dalam ni. 2.5 times 2, 5 lah. Okay, so tekan calculator in radian mode. Cos 5, lepas tu darabkan dengan yang depan ni. Pastikan tekan calculator betul-betul, jangan salah. So, V, awak akan dapat nilai V is equal to 0.284 meter per second. Unit jangan salah. Okay, so this is the answer. Alright, so finish example number 5. So, let's proceed to example number 6. Alright, so let's continue with example number 6. So, here we are given the equation of the displacement in function of time, where x is equal to 5 sine 20 pi t plus pi over 6. Okay, so where x and t are measured in centimeter. Okay, so from the equation, so let's write the equation first in order to answer question A, where x equal to 5 sine 20 pi t plus pi over 6. Okay, so from this equation, we can see here we have the value of maximum displacement, which is the amplitude. Alright, and then this is the omega. Okay, so untuk jawab soalan pertama, so we want to determine the amplitude where A is equal to 5 cm. Okay, kalau you nak tukar dalam meter pun boleh, tak ada masalah. Okay, and then the time taken to perform 5 complete oscillations. So, kita nak kira berapa masa yang diambil to complete 5 oscillations. Okay, tapi sebelum kita kira, untuk 5 ayunan lengkap, so kita kena kira the period T, where T is the time taken to complete 1 oscillations. Okay, so macam mana kita nak kira period? As we know that period can be calculated from the value of omega. Alright, so still A2, here is A2, where omega equal to 2 pi over t, and t is equal to 2 pi over omega. 2 pi, omega kita dah dapat daripada equation, which is 20 pi. So, we can cancel out pi. So, kita kira elok-elok, kita akan dapat capital T, which is the time taken to complete 1 oscillation, is equal to 0.1 second. Okay, therefore, time taken, okay, time taken to complete ataupun to perform 5 complete oscillation is equal to 0.1 second times 5, and the answer is equal to 0.5 seconds. Okay, so finish part A. And then let's proceed to part B. How to calculate the maximum speed of the particle. So V maximum, the equation is equal to A omega. Alright, so for this case, we have the value of A, where A is equal to 5 cm. Kalau you tak tukar dalam meter, jawapan nanti mesti dalam centimeter per second. So 5. Omega kita dah dapat 20 pi. So V maximum should be equal to 100 pi centimeter per second. Ataupun you nak tulis V maximum. Okay. Jawapan dia awak nak kira siap-siap pun tak ada masalah. 314.2. Unit mesti betul lah centimeter per second. Okay. Boleh. Tapi soalan tanya lagi, at what position? At what position would this value be attained? Always remember, okay, that V is maximum. V maximum dekat mana? Okay, always remember that V maximum at equilibrium position. Okay, V akan maximum only at equilibrium position, ataupun kita boleh tulis at X equal to 0 centimeter. Okay. At X equal to positive or negative A, which is at maximum displacement, the amplitude A, V is equal to 0. V tidak maksimum pada positive A ataupun negative A. Boleh? Alright. So now question C. Determine the magnitude of the velocity and the acceleration when the particle is at 3 centimeter from its equilibrium. Okay. So, we want to calculate what is the velocity and the acceleration. Okay, tapi kali ni kita tak diberi masa. So, we are given the position of the particle at X equal to 3 centimeter. Okay. Ingat dalam video short notes animation saya ada nyatakan. Okay, we have two equations of V, which are in terms of X and in terms of T. Same goes to acceleration. We have two equations of acceleration, which are in terms of T and in terms of X. Okay. So, untuk jawab soalan C ni, kita kena tulislah equation V kita mesti dalam in terms of X. Where V is equal to omega square root A squared minus X squared. Where here we have X equal to 3 centimeter. So, kita akan guna equation ini. Okay. So, V omega kita dah dapat tadi 20 pi square root amplitude is equal to 5 cm minus 3 cm. So, jawapan V nanti mesti dalam centimeter per second. Okay. Kalau you tukar ini dalam meter, A dalam meter, X dalam meter, pastikan unit awak dalam meter per second. Tengok, you buat tu, you tukar tak dalam sentimeter? You tukar tak dalam meter? Ataupun you biarkan dalam sentimeter? Unit jawapan akhir mesti betul. Kalau tidak, you akan hilang markah. Okay? And then, what is the acceleration? So, we want to calculate the magnitude. Okay? So, we ignore the direction, where A is equal to omega squared X. So, this is the equation of acceleration in terms of X. Okay? Alright, so now we can write A is equal to omega 20 pi squared. X is 3 centimeter. Therefore, acceleration is equal to 1.18 times 10 power of 4 centimeter per second squared. Jawapan kena betul. Dengan unit yang betul lah. Okay? Alright. So now let's proceed to the last part, which is question 6D. Okay, kita tengok kat sini. Okay. So 6D. Determine the initial position of the particle before it starts to undergo simple harmonic motion. Kalau kita perhatikan, equation yang diberi dalam soalan ini ada phase angle. Okay, that's mean the initial position of the particle where at t is equal to 0 second tidak pada initial position dia bukan pada equilibrium position. Okay, so soalan suruh kita cari. So at t is equal to 0 second, the position of the object dekat mana. Okay, so we just substitute in the equation of displacement in terms of time here. 20 pi t plus pi over 6. Okay, so 20 pi times t. T ni kan kosong kan tadi. So ini akan jadi kosong lah. So kita hanya ada sin pi over 6. You tekan calculator, you akan dapat jawapan dia. Make sure you punya calculator dalam radian mode. So x is equal to 2.5 cm. Okay, and what is the initial speed? Okay, at t is equal to 0 seconds, what is the initial speed v? Okay, so v dia mesti tulis equation v in terms of t lah, where v is equal to a omega, differentiate sin akan dapat cos, so dia akan dapat macam ini. Okay, differentiate sin akan dapat cos. Okay, saya tulis general equation dia dululah. Sekejap So general equation untuk v, okay, differentiate sin akan dapat cos. So differentiate again, omega t akan dapat omega. So a omega cos omega t plus the phase angle. In this case kita ada phase angle lah. So a adalah 5 cm, omega is 20 pi. So cos, okay, omega t, okay, kalau kita masukkan nilai t ni kosong, okay, so sini akan jadi kosong lah. Okay, so dia akan jadi cos pi over 6. Tekan kalkulator elok-elok, you akan dapat v is equal to 272.1. Unit dia centimeter per second. Okay, sebab kita tak tukar pun ni. 5 cm ni memang dalam centimeter lah amplitude ni. Okay. Alright, so finish example number 6. So let's proceed to example number 7.